When people think of ball bearings, they usually see them as basic mechanical parts. But in the world of DIY, a ball bearing can be repurposed as a signal receiving component for homemade antennas. Simple, easy to find, and surprisingly effective for signal experiments. And here's something you probably wouldn't expect. Old phone chargers, even if they're no longer in regular use, can still be repurposed as the housing for a homemade antenna device, with the ability to help decode radio signals surprisingly well. The first step is to use a knife to pry open the top cover of the charger. Take your time and be careful, especially if you have long fingernails, since a small slip can easily lead to an unnecessary injury. Once the cover is removed, use pliers to gently pull out the circuit board inside the charger, getting it ready for the next soldering step. Next, we'll solder 2 additional contact points onto the circuit board, using a standard soldering method to ensure solid and reliable connections for the next steps. To allow the circuit board to connect with the signal receiving component, I'll solder 2 copper wires onto the 2 contact points we just finished in the previous step, preparing it for the next stage of assembly. That last step can be quite challenging, since solder melts very quickly, making temperature control harder than it looks. For those who are new to soldering techniques, this part can definitely take some practice and patience. Reinstalling the circuit board the usual way can be quite tricky. That's why we'll drill 2 small holes in the charger cover, just enough to feed the 2 copper wires through cleanly and make the assembly much easier. As you may already know, ball bearings are components with extremely wide applications, found in everything from industrial machinery and household appliances to compact mechanical assemblies. Thanks to their precise metal construction, high durability, and stable electrical conductivity, ball bearings are not limited to mechanical motion alone and can be repurposed for other uses as well. Their circular shape, continuous metal surface, and effective interaction with electromagnetic waves make them a practical choice as a signal receiving element in homemade antenna devices. Simple, efficient, and easy to source or replace. Here, I'm using a cable with a built-in USB connector, which is very convenient since it can plug straight into the phone charger while also allowing an easy connection to the coaxial cable during assembly. This is a coaxial cable, a type of cable commonly used for signal transmission with high stability and low interference. Thanks to its structure, featuring a central copper core and insulating layer and an outer shielding layer, coaxial cable is well suited for signal reception and transmission, especially in homemade antenna projects that require clean and reliable signals. Using one end of this cable, I'll connect it to the wire that already has a USB plug, completing this part of the connection. One small reminder: be sure to wrap electrical insulation tape securely around the connection point to ensure safety and prevent short circuits during use. For the other end of the coaxial cable, I'll attach a straight F connector and a 90-degree F connector, making it much easier and cleaner to connect the setup to a TV. Following the correct assembly order, I'll install the straight F connector first, and then attach the 90-degree F connector afterward. When it comes to an antenna base, nothing really works better than a portable power strip. Solid, easy to find, and surprisingly convenient for supporting the entire setup. And that's it, the entire assembly is now complete. Now I'm going to take it out and test it right away to see how it performs in real conditions. Before connecting the homemade antenna to the TV, I'll show you first that the TV is currently receiving no signal, just to keep everything clear and transparent during the test. After just a few seconds, the TV signal has already stabilized. However, to determine whether it can maintain reliable performance over time, we'll need to monitor it a bit longer. After waiting for a while, there doesn't seem to be any negative or unstable signal issues. So I decided to disconnect it and plug it back in just to see how the system responds. And at this point, the entire testing process gives us a fairly clear answer. Using simple, familiar components, many of which are often considered disposable, we can still build an antenna device that works reliably and delivers real results. This shows that DIY isn't just about assembling parts for fun, but more importantly about how we observe, understand, and make use of what's already around us. This project may not be the perfect solution, but it proves that with a bit of patience, curiosity, and a willingness to experiment, you can create things that initially seem far more complex than they really are. And who knows, this small experiment might spark new ideas, better improvements, or even solutions that fit your own needs more precisely. If you found this video helpful, Take it as an invitation to start your next DIY project. Sometimes the greatest value isn't in the final result, but in what you learn and discover along the way with every attempt.